All right, y'all. So I'm about to work through numbers 5, 7, 9, and 10. So if there's only one of these that you need to look at, feel free to skip ahead. 5 and 7 are ones I anticipated us needing to look at because each one of them has some interesting pieces when we're simplifying radicals. As always, I'm going to encourage you to simplify before you start. So in problems like these, there's usually some like fancy simplifying that can happen by using prime factors. So I am going to break down that 4 into a prime factor of 2 times 2, especially because I realize that I'm going to be multiplying it by this fraction here, which has a 12 in the denominator. And I happen to know there's a 4 there, so those are going to end up canceling out. So I want to keep that part of my problem right now. So I'm going to break this down into the square root of 2 squared over 3. And then inside here, 7 is not really a helpful factor, particularly given what the other pieces that we're looking at here. So I'm going to pull out the square root of 49 as 7. And then I'm going to take that 12. I know that's 4 times 3, so I'm going to make that 2 squared times 3. And again, those are going to be factors that are going to cancel out soon. So that's going to be subtraction there. And this is going to be, let me just go ahead and make that a little square root, break it up into their little pieces. So let's make this 32 is 8 and 4. So that's 3 2's and then another 2. So this is going to be 2 to the 5th here over square root of 3. So looking here, we're already recognizing once these pieces cancel out, we're looking at some like denominators. So right now, when I go to multiply, I'm going to multiply my first terms, and my first giant denominator is 2 squared times, that 7's on the outside. So that's 7 times 2 squared over the square root of, now we have 3 squared times 2 squared. This is outside the radical, so this is 7 times the square root of 2 squared. This is already under the radical, so now I have 2 3's, 2 2's. That is being subtracted by, well, this is 2 squared times the square root, or the square root of 2 squared, times the square root of 2 to the 5th. So this is going to be minus the square root of 2 to the power of 7. And then in my denominator, I am doing root 3 times root 3. So I have the square root of 3 squared. So when I go to simplify here, I've got under the radical 2 squared. Under the radical, I've got 2 squared. So that piece is going to cancel out with that piece. So there's nothing left underneath your radical in the top. So that just becomes 7. In the denominator, you have the square root of 3 squared. Well, the square root of 3 squared is 3 because you have 2 3's. It takes 2 of them to get 1 out. So we have 7/3 here. In this second piece, we know that we have 7 2's. It takes 2 to get 1 out. So 7 divided by 2, that's going to give you 2 to the 3rd power. And then you still have a 2 left in there. And then again, we have the square root of 3 squared is again 3. So this is going to simplify pretty nicely, but we do see we still have a square root of 2 under the radical. So this is going to give us an irrational solution. So right now we have 7 root 3 minus 2 to the 3rd power is 8 root 2 over 3. So that would be an acceptable answer here. However, we do recognize that we have like denominators. So this is also 7 minus 8 multiplied by the square root of 2 over 3. All right, stay tuned for number 5. Number 5 is looks very complicated, but it actually comes down to a rational solution. All right, so when I did this one the first time, I simplified wrong, and then I got really mad. So here we are for the second time. So I'm going to start breaking these up into prime factors. So on the outside here, I'm still going to have 7 over 2. Here, this 5, just since I'm working with fractions, I'm going to make it 5 over 1 plus, I'm going to open up a big square root here. I know that 63 is 9 times 7, so that's 3 squared times 7 And 288, that's 144 times 2. Uh, so 144 times 2. So that's 12 times 12 times 2. So each one of these 12s is 2 2s and a 3. So that's going to be another 2 2s and a 3. So this is going to become 3 squared over 2 to the 1, 2, 3, 4, 5. 2 to the 5th. Then I'm going to close up those parentheses and I am subtracting. So I know that 8 is 2 to the 3rd, and then this is going to be 10 times 10 times 7. 10 is a 5 and a 2, so this is going to be 5 squared times 2 squared times 7. All right, so let's see if there's anything we can do to simplify as we're moving along here. Well, here I see this piece, so let's go ahead and eliminate that. Oh, and there's some simplification here. So let's go ahead and write that step down. So we've got the square root of 7 over 2 multiplied by 5 over 1 plus the square root of 7 over 2 squared. Let's close that up there. And then we are subtracting the square root of, well, this piece right here stays, stays. Oh no, because we got some 2's here. So these are going to cancel out, and this is just going to be 2 to the 1st power. So this is going to be 5 squared times 7 over 2. All right, so let's see what happens when we continue working through here. Have we made any mistakes? Yes. Why does that say 2 squared? This should be 2 to the 1, 2, 3, 4, 5th. Huh, I wonder why I wrote that. So that should be 2 to the 5th. So if you are wondering if I've lost my mind, apparently the answer is yes. So let's go back here. This is still 2 to the 5th. All right. So let's continue here. So as I go to multiply here, I'm going to multiply my numerators. I'm going to multiply my denominators. So I want to be careful. This 5 is outside the radical. This is inside. So this is going to be 5 root 7 over, well, I have the square root of 2 multiplied by 1, so it's just going to be over the square root of 2. I am adding this to, well, this is the square root of 7 times the square root of 7, so that's the square root of 7 squared over, well, this is the square root of 2 to the 1st times the square root of 2 to the 5th, so this is the square root of 2 to the 6th there. And then I am subtracting, no more multiplying. So I can pull out this 5 squared, I can pull out a 5, so this becomes 5 root 7 over the square root of 2. So as you go to look at this problem here, you happen to see that you have 5 root 7 over the square root of 2 minus 5 root 7 over the square root of 2. So those pieces cancel out. And we have the square root of 7 squared, so that's 7. And then we have the square root of 2 to the 6th. Well, that is 2 to the 3rd. So we actually end up with 7 over 8, which is a fraction. And so a fraction is the definition of a rational number, so there is your rational solution. So for number 9 here, you really have to read. So it says she's fencing. Fencing always means perimeter. A new area. She is using this figure, so you have to find the perimeter. It tells you perimeter. And it says the fence is to be made of 4 strands of barbed wire minus an 8-foot gate. So it wants to know how many feet of wire she needs. So basically, you need the entire area or the entire perimeter 4 times, but then you need it 4 times because you're fencing it, like as you fence it, it needs 4 strands. So if I want to fence this, I need 70 times 4. And then we have to take away the gate. Well, the gate also has 4 strands of barbed wire. So I'm really going to be taking away 8 times 4. I'm really going to be subtracting 32 away from the perimeter at the end. So if I want to start by getting my perimeter, I'm going to start by just getting the perimeter and then multiplying it by 4. So when I go to get this perimeter, I'm adding my side length. So I know that I'm adding 40 plus 110. So I'm getting 150. And then I'm going to add in the 70. And then I'm going to add in the square root of 3200. Well, I should already know that I'm going to have to start breaking down these radicals. So I've got my 150 added to my 70, so I'm already dealing with 220. And then I know that this is going to break down into 320 times 10, or actually making more sense there. Let's go ahead and make that 100 times 32. So 100 times 32, this will help us keep breaking down this perimeter. So that's 220 plus, well, this is gonna, let's keep finding some perfect squares. So that one's 100 times, well, 32 is 16 times 2. So I can pull out a 10, I can pull out a 4. So it's 220 plus 10 times 4 to the square root of 2. So if I only needed one thing of fencing and not 4 things of fencing, I would need 220 plus 40 root 2 feet, or whatever it says that it is. So now that I have that, I know that I need 4 pieces for the for each meter. I need to put 4 strands. So I'm going to multiply by 4 here. So I'm going to take 220 times 4, and that's going to give us our 880 here. And then I also need to multiply my coefficient there by 4. So I'm going to get plus 160 root 2. Now, it does tell us we have a gate. So when I find the gate, I am just subtracting away 32 square feet. So when I do 880 minus 32, I'm going to end up with 848 plus 160 to the square root of 2 as the final amount that they will need, with 4 strands of barbed wire per fencing unit and the piece of the gate taken away. Oh, and by the way, when you were, it asked you to give a decimal solution apparently. Oh good, and now I lost my pen. Like I put it down. Oh, found it. It was in my hand. So right now I'm going to figure what that would be in my calculator, and I'm at 1074.27. So if you got something right around there, chances are you did it. You might have rounded at a different time, but that is what that becomes as a decimal. All right, number 10 here, you got to draw yourself a picture to help yourself out. So it says he bought a single square canvas with an area of 3 square meters. So I have a square. The area of the square is 3 meters squared. So it wants to know what's the perimeter of the canvas. It wants to know if the perimeter is rational or irrational. So it says, note, the length of one side of the square is the square root of the area. Wow, so they really do the thinking for you there. So it's saying the length of one side of the square is the square root of the area. So it's saying that this is the square root of 3. You also can figure that out. If you had a square with an area of 64, you've got 8 and 8. Well, that's because the square root of 64 is 8. If you've got 100 here, you've got 10 and 10 because the square root of 100 is 10. So whatever is the area, you take the square root of it, that gives you the side length. So you're looking at a square where your side lengths are all the square root of 3. So it says, what is the perimeter of the canvas? Well, if you want the perimeter, it's root 3 plus root 3 plus root 3 plus root 3. So that would give us 4 root 3. So 4 root 3, because it contains the square root of 3, is going to be irrational because this is a non-perfect square. And anytime you have something containing a non-perfect square, you're looking at something that is irrational. All right, guys, I hope that helped. Don't forget there is the next unit's already posted, Walch 3.3. There's an instructional unit. There's a really fast skill check in Canvas. You'll see it'll take, or not in Canvas, in Delta Math. It'll probably take you 5 minutes. It is not like a normal Delta Math assignment. It's just to make sure you got the process of converting. And then I will catch you guys again on Friday when we continue working with converting between fractions or rational forms. So, like working with a radical to working with fractional exponents. All right, bye.